Hello everyone, you're welcome to Martin's tutorial. Today we'll be looking at integration. What I call it? Integration. This is a problem on the board. How do we go in solving this problem? Now, when you see a problem like this, there is a principle in integration we need to apply. And that principle is called integration by substitution. How do we need to go about that? Now, follow me. Now, you see something like this, the first thing you do is to bring your solution. Then you say let. You can use any letter you want, but I want to make the function inside the bracket to be my u. So I can say let u. You can decide to use z. You can decide to use any letter of your choice. So let u be what is inside the bracket. That is 5x raised to power 3 plus 9. You don't need to touch the power. A time is coming whereby we need that, but now you don't touch it. This is our u. So what we need to look at now is to find the derivative, that is the change between this and this. And how do we do that? You say the change, which is du over the change dx, because we are making use of x here. That will be du over the x equals to, let's differentiate this together. Of course, the very easy way to differentiate is that use the coefficient of x cubed to multiply with the power. The coefficient of x raised to power 3 here is what? 5. Then 5 times 3, it will give us what? 15. Then you still bring down your x raised to power 3. You know, in differentiation, we subtract from the power. That is minus 1. Then this is a constant number. It has to change to nothing rather than what? 0. So this one has automatically turned to 0. And that's why we are not going to add it here. So in this now, we are going to have 15x raised to power 3 minus 1 will give us what? 2. Are you seeing that now? Then the next thing now is to get our d. Let's bring this now as our du dx. That will give me 15x squared. Now, I need to make du the subject of formula, like standing alone. That will be du is equals to, you cross multiply 15x squared times dx. That is 15x squared dx. You can see that we have our du to be this. At the same time, we need to make dx the subject of formula. Let it stand alone, just like this du is standing alone. That is dx. The x, I mean to say, equals to, what is here? Du. Then all over 15x squared. 15x squared. All I did there was to divide both sides by what? Coefficient of the x, because I want x to stand alone. So after that, what we need to do now is to apply the principle we are making use of, which is integration by what? Substitution. Now look at this. Let me continue from here. Just follow me. I just need to bring back the function as integral sign 5x squared, then open a bracket, 5x cubed plus 9 raised to power 4. Then the what? The x. Of course, this is the x here. Now, with this, we are going to substitute the value of du, dx, and u into this function. And look at what we're going to do. It will be integral sign 5x squared. Then what is our 5x cubed plus 9? That is what we called u. Then you bring times, which is dot. We can use dot to represent times. Then you bring what is your u. Then this is our u, which is this inside the bracket. You say u, instead of you putting the number again, you bring u to avoid complication. So it will be u raised to power what? 4. Then times, which is still dot. The x, what is at the x here? You can see what are the x is equals to du over 15x squared. That will be du all over 15x square. We are not done. Now, let's continue. All the next thing I need to do now is to come here and say 5 here, 5x square can cancel here. 5 in 15x square remain 3 here. So what we have left is, there is 1 here. 1 times u raised power 4 to give me u raised power 4 multiplied by what? du. Then all over what? 3. Now you can see this. We move on. As we are in this process now, the next thing we need to do now is to start integrating them one after the other. And anytime you start to integrate, this thing will no longer appear. At the same time, this thing will no longer appear. This will be represented with a constant variable, which is c. We use c to represent the constant numbers. So it will now be u, let me still put this, u raised to 4 dot, let me change this to dot, then d raised to power this, do not forget, is like this. Now look at what I want to do now. It will now be, if I want to integrate this, the power is 4. The power is what? 4. So all you need to do is to come here and write the same u raised to power 4. Then integration, we add 1 in the power, it will be plus 1. Then all over, whatever thing you have added in the power will become your denominator, which is 4 plus 1. 4 plus 1. You can see we have the same thing as the power to be the denominator there. Then after that, you still put your dots. What do we have here? This one is what? We can see say 1 all over what? 3du. Now, look at this. We can stop there now and say plus what? Okay, let's just continue this way. Let's just continue this way. Now, after this, we now have what we call u raised to power 5 all over 5. Then times, of course, dot means times. This du will no longer be there. It will now be times 1 all over what? 3. Plus c. Will no longer put the u because the du there just show the change, the rate of change in this function. So it has been converted to be a constant value now. Now, the next thing we need to do now is to apply, substitute. What was our u initially? In this place, look at here. You see this? Our u is 5x raised to power 3 plus 9. So anywhere I see u, I will put that now. That will now give me, open a bracket, 5x raised to power 3 plus 9. Close your bracket, raised to power what? 5. All over what? 5. Then times 1 all over what? 3 plus what? C. Can you see that? So the final answer now will now be, you bring what is here. When you use the bracket now to multiply with what is in the bracket to multiply with 1, you still have what is what in the brackets. And that will give you what? Now look at this. It will now give you, open a bracket, 5x raised to power 3 plus 9 raised to power 5. 5 times 3, of course this is times, all over what? 15 plus c. This is our final answer. Can you see that? Is it hard? Of course, it is not hard. All you need to do is to practice it. Just follow the way I do it and do the others that may come from any place. So, thank you. All I need you to do for me now is to like, comment, and share. With this, you can help this video to reach out to others. I still remain your maths teacher. Bye.